We're going to move on to the mechanics of breathing. Remember that air moves in and out of the lungs due to the air pressure gradient. And we can change the pressure inside the lungs, the intraalveolar pressure, by changing the lung volume. And we change the lung volume due to muscle contraction and relaxation. Boyle's law is really important, so make sure you know this. Boyle's law just states that the pressure is inversely related to the volume. So if the volume increases inside the lungs, as when you inhale, that will decrease the pressure inside the lungs, or the intraalveolar pressure. And then air will move down the pressure gradient from higher pressure outside the body to lower pressure inside the body, and that causes inhalation. And then during exhalation, the lung volume will decrease as the chest wall falls, and that will increase the intraalveolar pressure. And so now the pressure is higher inside the lungs than outside the body, and so air will move out and you exhale. Here's just a picture of Boyle's law. So the one on the left would be a larger lung volume. That would be when you're inhaling. And so with a larger volume, that decreases the pressure of the gases inside. And that's because there's more room for the gas molecules to spread out, and they're not going to be hitting the walls as much, because when they hit the walls, that creates the pressure. And then the picture on the right is when you're exhaling and the lung volume is smaller, that will increase the pressure because the space is smaller, and now the gas molecules are going to be hitting the sides more frequently, and that increases the pressure. So we also have to consider the amount of gas in the lungs as well. So we're going to use the ideal gas law. So the ideal gas law is just a modification of Boyle's law. So you can see we have Boyle's law with the pressure and the inverse relationship to the volume. And then the only other thing that we're adding here is the N, which is the amount of the gas that's in the lungs. We're going to ignore the R and the T. R is a constant and T is temperature, but we're not going to be changing the temperature of the air. So what the ideal gas law is just saying is that when you increase the volume, like when you inhale, that will decrease the intraalveolar pressure, so the pressure inside the lungs. But as you're inhaling, more gas enters the lung, and that will increase the intraalveolar pressure. This graph is really important to understand for how the ideal gas law works. The top graph is showing the intraalveolar pressure, and the bottom graph is showing you the breath volume. We're going to start right at the end of exhalation before we start to inhale. The atmospheric pressure is 0 along with the intraalveolar pressure. So since they're both 0, there's no air moving in and out of the lungs yet. And then you start to inhale and your chest cavity gets bigger. So as the lung volume increases, according to Boyle's law, remember, as the volume increases, the pressure decreases. So the intraalveolar pressure will decrease to -1. Air will flow into the lungs, and as the air flows in, that will increase the pressure of the lungs. So you're still inhaling, but notice that now the pressure is increasing, and that's because the ideal gas law, you've got the amount of gas in the lungs increasing, which increases the pressure. And then at the end of inhalation, before you exhale, the intraalveolar pressure is 0, along with the atmospheric pressure. So no air is going to move in or out at the end of inhalation. And then you start to exhale, and the lung volume will get smaller. And as the volume decreases, that will increase the intraalveolar pressure. So intraalveolar pressure will increase to +1, but you're still exhaling and the pressure starts to drop. And that's because the gas is moving out of the lungs. There's less gas in the lungs, and that will decrease the pressure. And so the intraalveolar pressure will go back down to 0 at the end of exhalation. So at the end of exhalation, before you start to breathe in again, the atmospheric and intraalveolar pressure are both 0 and no air is moving in or out of the lungs. So what's going to be creating the volume changes in the lungs are the muscles. So we have diaphragm and muscles in the rib cage. The diaphragm is shaped like a parachute, and when it contracts, it will move down towards the abdomen. So when you inhale, it's an active process. So diaphragm will contract, it will move down towards the abdomen, that'll increase the volume of the chest cavity, and the external intercostal muscles will contract between the ribs, and that will lift the chest wall out. And remember that the lungs are stuck to the inside of the chest wall by that suction cup, by that negative interpleural pressure. So that'll increase the volume of the lungs, decrease the intraalveolar pressure, and that'll cause air to move into the lungs during inhalation. During exhalation, it's a passive process. So the diaphragm and the external intercostal muscles just relax, and that will decrease the thoracic cavity size, and that will increase the pressure of the lungs, and that will cause the air to move out. You can make exhalation active, like if you're exercising to force out more airs. You can contract the internal intercostal muscles between the ribs and also the abdominal muscles to force more air out of the lungs. So let's just take a look at what happens during inhalation. So the diaphragm and external intercostal muscles will contract. It's an active process. Diaphragm will move down towards the abdomen. The rib cage will rise. And remember, the lungs are stuck to the inside of the chest wall by that negative interpleural pressure. And the lungs will expand along with the chest wall. So what happens to the thoracic cavity volume? That's going to increase. The lung and alveolar volume will also both increase. And if lung volume is increasing, the intraalveolar pressure will decrease. And so air is going to move into the lungs down the pressure gradient, going from higher pressure outside in the atmosphere to lower pressure inside the lungs. And then the opposite's going to happen during exhalation. So the diaphragm and external intercostal muscles relax, which is a passive process. The chest wall is going to fall inward, and that means the lungs are going to shrink in volume, and the thoracic cavity volume decreases, lung and alveolar volume both decreases, and if the lung volume is decreasing, that'll increase the intraalveolar pressure. So air is going to move out of the lungs because there's higher pressure inside the lungs than the atmospheric pressure outside the lungs. And this is just a nice picture from the side showing during inhalation how the chest wall rises and the diaphragm moves down, and that will increase the lung volume and air will move in. And then during exhalation, the diaphragm relaxes and moves back up, and the chest wall will fall back down. And that will decrease the lung volume and have air move out of the lungs. And this is just a front view, just showing you the lung volume at exhalation. Smaller volume, air will move out. And also the diaphragm is relaxed, it's moved up. And then during inhalation, you can see the chest wall is expanded outwards, diaphragm is moved down. That'll increase the lung volume and air will move in. And there's a nice little animation here if you want to click on that at home. This actually shows the lung volume changing as you're breathing in and out. And then this is just another picture, just looking kind of down from the top inside your chest cavity. This is during inhalation. You have an increased chest cavity volume, and that will decrease the pressure and allow more air to move in. And then during exhalation, the chest cavity will decrease in volume, and that will increase the pressure and the air will move out during exhalation. This graph is also important to know because it shows the change in the interalveolar pressure on the top and the interpleural pressure on the bottom. And remember, the difference between those two is the transpulmonary pressure. The transpulmonary pressure is the force across the lung wall, and that's the force for expanding the lungs. Where the transpulmonary pressure is the greatest force for expanding the lungs is at the end of inhalation. So you can see the transpulmonary pressure would be 0 minus a minus 6, so the transpulmonary pressure would be 6. And the lungs would be the most expanded at the end of inhalation. And then when the lungs are the smallest, the least expanded, would be when the transpulmonary pressure is the smallest, and that's at the end of exhalation. You can see the transpulmonary pressure would be 0 minus the minus 4, which would only be 4.